Okay, good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrell's Math Algebra class. Today we're going to wrap up inequalities, and we're going to talk about absolute value inequalities. Now, hopefully you guys are thinking, wait a second, absolute value, wait a second, we already learned how to do absolute value equations. Yes, sir, you did. If you remember learning that, the next question should be, is it the same procedure? And the answer is yes. The only difference is what? What do you think the only difference is? Yes, sir? Okay, when you multiply or divide by a negative, you must flip the inequality sign. Do you guys remember that absolute value, you have a positive and a negative side? Remember that? Remember the negative side, you multiply the non-absolute value side by a negative? Well, this time you got to flip the inequality sign. So technically, I should be able to say, have a good day, you can do the homework. I really should, because everything that I'm going to teach today, we have already learned. The only difference is that now I have an inequality sign instead of an equal sign. But of course, I'm not going to do that to you. I'm going to teach it. So let's review, guys, from the top. Absolute value, that is the distance from zero, which is represented with the symbol as shown right here. It looks like two parallel lines. That's the absolute value symbol. Solving absolute value equations is very easy, but you must remember that an absolute value has a positive and a negative side. For example, my friends, if I just tell you the absolute value of x equals 3, well, there are two possible answers for that. X can equal 3 or negative 3. Why? Well, since absolute value is a distance, if I have the absolute value of negative 3, that means I'm here at the negative 3. The absolute value of negative 3, that's the distance from 0. So that's 1, 2, 3 away. So the absolute value of negative 3 is 3. What about the absolute value of 3 proper? Well, that's also 1, 2, 3 away from 0. So the absolute value, sorry about that, guys. So since the absolute value of negative 3 is 3 and the absolute value of 3 is 3, what can we conclude? Well, we can conclude that the answer to an absolute value is always positive because it's a distance, but it has a positive and a negative root behind that absolute value. So there's always a positive side and a negative side to this absolute value. Okay. Knowing that absolute values have two sides make it much easier to solve absolute value equations and inequalities. We've already talked about equations. Today we're going to focus on inequalities. So let's start with a nice simple example. What are the solutions of the absolute value of x plus 3 less than or equal to 9? Well, you want to graph and check your solutions. Remember, when you're checking your solutions, sometimes you will have a value, okay, that does not work when you plug it back in. If you solve and you have a value that does not work, that solution is called extraneous. Okay? So, how do we do this? Very simple. Number one, first of all, we're going to isolate the absolute value. That means that if anything is being added to the outside of the absolute value, subtracted from the outside of the absolute value. Okay, so, sorry about that, guys. A lot of interruptions today. So the absolute value of x plus 3 is less than or equal to 9. You want to isolate the absolute value. If anything is being added to or subtracted from the absolute value, if anything's being multiplied to the absolute value or divided to the absolute value, you got to get rid of those, okay, using operations that we've learned to get the absolute value by itself. So in this case, how do we get the absolute value by itself? Yes, sir. You subtract 3 to both sides. That's absolutely correct. And when you subtract 3 to both sides, what are you left with here, gentlemen? Not x. No. Good. You're left with the absolute value of x is less than or equal to 6. So all of that was just step one, guys. That was getting the absolute value alone. Done. Now, step two. Step two is to split the equation or inequality into the positive and negative sides. Hope you guys remember that. If not, I'm going to just describe it right now again. But if you remember doing equations, you had a positive and a negative side, okay? Well, there we go. What happened here? Well, I took and I created my positive side, hence the blue plus sign. And then I went and I took my negative side, hence the red negative sign. So I split the equation into two sides. Now, how do I know what to do here? There's some differences here, Mr. Morrow, that I just don't understand. Let me explain them. To get the positive side, my friends, that is literally the mirror image of the original without the absolute value symbol. So you take exactly what's here, exactly, word for word, letter for letter, number for number, sign for sign. It's the mirror image, except you got rid of the absolute value sign. Does that make sense? You promise? Okay. Now, the negative side, my friends. For the negative side, you're going to multiply the non-absolute value side, which in this case is the 6, right? You're going to multiply the non-absolute value side by -1. Please note that if you are working with inequalities, you must flip the inequality sign of the negative side since you are multiplying by a negative. Whenever I multiply or divide by a negative, don't I have to flip the inequality? So look at what happened here. I multiplied this 6 by a negative, and I went from being less than to greater than. Why? Because it's my negative side. Does that make sense, guys? Yes? No? Maybe? Kind of? Sort of? All right, awesome. Step 3, solve both equations or inequalities and graph if needed. And then check your answers and graph if required. Okay, so in this case, I'm going to graph it. Here's my 0, here's my -6, here's my +6. X is less than or equal to 6, so closed circle shaded to the left. And it's also greater than or equal to 6, so closed circle on the -6, it's greater. So to the right, you're going to have an overlap, and this is an AND equation. Does that make sense, gentlemen? Okay. If I wanted to check, if they told you, check all of your answers, if they require you to do that, easy. What's a value inside of here? 4, okay. Put it into the original equation. Is the absolute value of the original equation was that? Is the absolute value of 4 plus 3 less than 9? What's the absolute value of 4? 4. What's 4 plus 3? Is 7 less than or equal to 9? So it works. Does that make sense, my friends? Do you have any questions before we continue? Because now we're just going to hit example after example. Yes, sir. Thank you. If you start with a negative, so then it would become a positive later. Let me explain what he's saying. Let's just say that I'm at this point right here. Absolute value of x is less than -8. Okay? You're still going to have a positive side and a negative side. My positive side is the mirror image. The negative side, I multiply the non-absolute value side by negative. So that becomes x is greater than +8. Does that answer your question, son? Thank you so very much. Good job. Sir, you had a question, my man? Anyone else have any other questions on this? Okay. Thank you. Okay. Let's solve and graph each absolute value inequality. Okay, my friends. A, Is there anything that I have to get rid of to get the absolute value alone here? No, very good. It's all alone already. So I'm going to split it up into my positive and my negative side. My positive side is the mirror image. So it's exactly what I see without the absolute value sign. It's exactly what I see without the absolute value side. My negative side, though, I'm going to multiply the non-absolute value side by a negative. And I'm going to flip the sign. So this is n minus 1 is now greater than or equal to negative 2. Before I proceed to solving, I need to know that you guys see what I just did. You promised me. Thank you. Very, very good. High five. You switch the inequality sign because you multiply by a negative. That's exactly right. If you get that, you're going to do great on this. So let's solve. Add 1 to both sides. N is less than or equal to 3. Add 1 to both sides. N is greater than or equal to negative 1. Now, let's graph it. So I have negative 1 and 3. N is less than or equal to 3, but it's greater than or equal to negative 1. So what kind of an inequality is that? An and or an or? It's an and. So I have to write my final answer as a single inequality. So N is greater than or equal to negative 1, but less than or equal to 3. That, my friends, are my final answers. If it's an or equation, inequality, or graph rather, I can leave them separated, right? But if it's an and compound inequality, I must combine them. It's just the way it goes, okay? Does that make sense, guys? All right, let's keep moving. Okay, for B, what do I have to do first to get that absolute value alone? That's absolutely right. I subtract 5 to both sides. So I've got the absolute value of x minus 4 is greater than or equal to 8. I'm going to go ahead and split it up into my positive and my negative sides. Remember, you don't have to watch me do this. At this point, you could be doing it on your own. So I got x minus 4 is greater than or equal to 8. And x minus 4 is less than or equal to negative 8. Whoa, 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 why? Because I multiplied the non-absolute value side by a negative 1. So now I add 4 to both sides here. X is greater than or equal to 12. I add 4 to both sides here. X is less than or equal to negative 4. So let's graph it. Let's see what kind of an equation we have. Or inequality. I have negative 4 and 12. X is less than or equal to negative 4. Closed circle shaded to the left. And it's also greater than or equal to 12. Closed circle, shade to the right. So that's an or compound inequality, and I can write my ors as separate inequalities. So I could say x is greater than or equal to 12, or x is less than or equal to negative 4. And that, my friends, are my final answers. Does that make sense? Yes, sir, my man. I'm sorry, my man? This is an OR problem because the graph proved that it was an OR problem. The graph proved that it was an OR, nothing else. I can't look at these and know if they're an OR or an AND. I have to graph them first. Then once I graph them, I know if I have to put it as a single inequality, if it's an AND, or if I leave them as separate ones, if it's an OR. Thank you, my brother. Because look, this was the single one, because that's an AND. Thank you, sir. Okay, your favorite. Let's throw some fractions up in there. All right, what do I got to do here first to get the absolute value alone? That's absolutely correct. So I'm going to have the absolute value of x plus 2 1/2 is greater than or equal to 3 1/2. Now I'm going to split it up into my positive and negative sides. So I have my mirror image, x plus 2 1/2 is greater than or equal to 3 1/2. And I have my negative side, which is x plus 2 1/2 is less than or equal to negative 3 1/2. Remember, I have to multiply the non-absolute value side by a negative, which flips the inequality. Now I subtract 2 1/2 to both sides. So x is greater than or equal to 1. I subtract 2 1/2 to both sides. X is less than or equal to negative 6. And now I got to graph it and see what kind of an equation I have. Do I have an inequality? Do I have an and or an or? Here's 0, here's 1, here's negative 6. X is less than or equal to negative 6, and it's greater than or equal to 1. So is that an and or an or? That's an or, so I can leave them separated as answers. X is greater than or equal to 1, or x is less than or equal to negative 6. You have a question, my man? No worries. Thank you. Does that make sense? Okay. Oh, look at this one. This is a good one. Okay. What do I got here? What do I have to do here? Absolutely right. You subtract 16 to both sides. And I have negative 2 times 4x plus 5 in absolute value is less than or equal to negative 6. Now what do I have to do? No, I don't distribute. You don't distribute ever with the absolute value. You get it alone, so you divide by negative 2. Very good. So now I have the absolute value of 4x plus 5. Did I divide by a negative? What do I have to do with that inequality then? Flip it. Very, very well done, gentlemen. And now the absolute value is alone, so let's split it up into my positive and my negative sides. My positive side is the mirror image. 4x plus 5 is greater than or equal to 3. My negative side, I multiply the non-absolute value side by a negative, so that becomes 4x plus 5 is less than or equal to negative 3. Subtract 5 to both sides. 4x is greater than or equal to negative 2. Divide by 4. X is greater than or equal to negative 1/2. On my negative side, I subtract 5 to both sides. 4x is less than or equal to negative 8. Divide by 4. X is less than or equal to negative 2. Now let's graph it. Okay, let's graph these. I don't want to get confused. Let me just do that. Okay, so I've got 0. I got negative 1/2. I got negative 2. X is greater than or equal to negative 1/2, closed circle to the right. X is less than or equal to negative 2, closed circle to the left. Is this an and or an or? So I can go ahead and leave them as separate inequalities. And that there, my friend, is how you solve compound inequalities. Sir? I'm sorry? You do division before subtraction? No, sir. That's in the order of operations, but when we're working with equations, you undo addition and subtraction first, then you undo multiplication and division. If I were you, I would go back to the videos on solving equations. Thank you, sir. All right, your favorite word problems. It's going to be part of your life. I could either ignore it and hurt you later because you wouldn't know, or I can take the challenge now and make you guys understand this. So I'm going to take the challenge. First of all, guys, the absolute value equations are really, really simple, actually, if you learn the formula. Always set up absolute value word problems using this formula. It's x, what you're looking for, minus the desired amount or the goal. And then less than or equal to the change or the variance. Variance is change. And you can have less than or equal, or you can have greater than or equal to. It really depends on what they ask you. But the main equation here is x minus the desired is either equal to, less than or equal to, or greater than or equal to the change or the variance. If you know that formula, this is actually quite a joke. For example, a company makes boxes of crackers that should weigh 213 grams. A quality control inspector selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range allowable? What is the range allowable weights for the box of crackers? Well, I have my x minus my desired. What is my desired here? What is my desired here, guys? It should weigh 213. And okay, any box that varies from the weight by more than 5 is sent back. So what is it going to be here? It's going to ask, no, it can't be greater than. If it's greater than 5, it gets sent back. So it must be less than more than 5. So yeah, it could be equal to, though. Less than or equal to 5. That's my equation. Now it's Mickey Mouse. I set it up into my positive side and my negative side. So x minus 213 is less than or equal to 5. X minus 213 is greater than or equal to 5. Add 213 to both sides. I'm sorry, negative 5, yeah. Yeah. Oh, look what I just did. This is negative 5. Yes, sir, thank you. I should pay attention. Good catch, my brother. So plus 213 plus 213. X is less than or equal to 218. Add my 213. Add my 213. X is greater than or equal to 208. Okay? So it can be less than or equal to 218 or greater than or equal to 208. So if I had to graph this, here's 208, here's 218, has to be between 208 and 218. Does that make sense, guys?
Yes.
It's really simple, isn't it? As long as you just know the formula, my brothers. Okay. Yeah, this would be an AND graph. Yes, so this would be a single inequality. Thank you, my brother. And that would be, it's got to be greater than or equal to 208, but less than or equal to 218. Very good, son. Okay, how about here? A food manufacturer makes 32-ounce boxes of pasta. Not every box weighs exactly 32 ounces. The manufacturer allows at most a 0.75 ounce variance. Write and solve an absolute value inequality to find the range of allowable weights. Well, I have x minus desired. What's my desired weight here? 32 ounces. Less than or equal to, what's my variance? What's the change? 0.75, very good. So now, positive side, negative side. Positive side is the mirror image. Negative side, I multiplied the non-absolute value by a negative, flipping the sign. So I add 32 to both sides. X can be less than or equal to 32.75. I add 32 to both sides. X can be greater than or equal to 31.25. So this box can be between 31.25 and 32.75. Does that make sense? Yes, sir. Yes, of course. Thank you. So this is going to be x is greater than or equal to 31.25 and less than or equal to 32.75. Okay? All right. Now, I'm going to skip this one for a second because I want to just show you two special cases. Okay? Two special cases. Try to do that word, not try, do that word problem on your own. If you have any questions, come see me. Okay. Look at what happens here, guys. I've only got 2 minutes, so I'm going to go kind of quick. I have my positive side and my negative side. So I got x minus 6 is greater than 2, and x minus 6 is less than negative 2. Okay? And I think I messed up here, but I don't know. We'll see. So, no, this is fine. Yeah, this is regular. I think I messed up there. Okay. Yeah, I think I messed up here. This is, let's look at B. I'm sorry for the confusion. Let's add 5 to both sides. The absolute value of x plus 12 is less than or equal to negative 1. Hold the horses. Can an absolute value ever be less than a negative? So if you see that right off the bat, it's no solution. It's no solution. And the mistake I made here, this should have been a negative 2. Okay? Think about this. Do I even have to solve this? Doesn't an absolute value always have to be greater than a negative? However, can it be equal to a negative? No. So this would also be a no solution. An absolute value can never equal a negative, and it can never be less than a negative. So that's why these two special cases are no solution. And now, I know I'm going backwards, I'm acting like a crazy man, but real quick, the water pressure should be 162.5. Its variance is 12.5, so basically, x minus desired is less than or equal to the change or variance. You can solve that one on your own. Thank you very much. Have a great day. I hope you learned a lot.